Hello and welcome back to the second session of this programming exercise. Also, I am very sorry for the bad audio quality on this. I've recorded this while using a different microphone and I realized only afterwards that the wrong microphone was turned on. I hope it's still okay and the next one will be with the better recording again. I'm trying to keep this a little shorter this time. 1 hour and 15 minutes is very long and I hope it wasn't too overwhelming. I re-watched the video and I realized this was lots of different steps at the same time. But first of all, I realized we can do some optimizations. We had a lot of errors that occurred because when the deck was empty, the loop ran into functions it was calling when he couldn't call, it couldn't call the array, and this particularly happened here. So we divide the number of cards by 2 and use the integer part to determine how many rounds of giving out cards we need. And obviously if we do this to a certain amount of players, then for example here this divided by 2, we could also divide this by the player count. So if we have 3 players, then we don't need as many rounds giving cards if there are more players receiving cards. But nevertheless, if we have 4 cards and 3 players, the first round will give every player a card, and the second round will fail after giving out the 4th card because the second player cannot get the 5th card because there is none. So in this case here, when this will happen when the deck remaining is 0. So one thing we can do here is if deck remaining equals to 0, then break. And what this does, it breaks out of the current loop that we're in. So this J for loop will then cancel, and we could give a message here maybe so we see whether this is happening. Print on no more cards to hand out. And now if we run this and we put this as player counts 3, then we should hopefully not see an error message. We did see an error message. Attempt to access 2-element vector. Okay, this didn't work because we did not initialize this here. Here we have 2 empty decks that we add to the decks, and obviously we need 3 if we have 3 players. But since we're assigning this dynamically, it might make sense to add them dynamically as well. So we could do for I in 1, 2 player count, and here we would just initialize this empty. So the decks does not have any decks. And here we would basically say push, and we want to add to the decks an empty array and only 1 empty array. And what this does is it gives us a very empty decks set and then adding 3 empty decks to the deck set. So if we call this, we see now we have 3 empty car vectors in our whole deck vector. So now if we run everything, the deck has 4 cars in total, round 1, deck has 4, 3, 2, and then it did it break? I'm not so sure whether it broke, so let's start over again. If deck remaining 0, then print line no more cards to hand out and break. So deck size 4, 3, 2. The deck has 4 cards in total. Oh yeah, an interesting thing that happens. So this thing here, the cards count divided by player count. If we have 4 cards and divide that by 3, that is 1.3, and we remove the everything behind the decimal point, so it only goes for 1 round, so the last card is not handed out to a player. And that could be how we want it to be, but we could also say, okay, let's hand out all the cards every time. So we just do one more round, even if there is not a full set of cards available for every player. So by random chance, the first player will get more cards. And now we see, okay, there's round 1, 4, 3, 2. Round 2, deck size is only 1, no more cards to hand out. And now the first player should have, if we go in here, 2 cards. Second player has 1 card, and the third player has 1 card. So the 4 cards were now not evenly distributed, but I guess that's okay. And we can now basically go back to 2 players, because everything that does something differently depends on the player count. If we start all over again, where does the problem happen now? Player count. Maybe because I didn't reinitialize everything. So let's restart. Sometimes that already solves your problem. No. No more cards to hand out. Okay, because obviously this thing doesn't work anymore. So yeah, we don't want to print the deck for the third player that no longer exists. In this case, we decided who plays first. The first player was player 1, and we will now start with actually playing the game. In this case, they have 2 cards. We don't need to shuffle the cards because they were shuffled here in the beginning because we drew random numbers from the deck. And the active player will look at this card and pick a value to compete with. And to draw something from an array, and the easiest way to do this is by calling the pop function. So we can do pop or pop first. Pop will draw the last card, and pop first will draw the first card in the array. And we will do this from the player that is whose turn it is. First player. Let's see if this works. Yeah, it draws the top card, in this case, the Nissan. Interestingly, by drawing the first player, now it is not as we would make sure that everyone draws a card, and I guess from this on we'll stick with 2 players to keep it simple. And you could, as an exercise, try to extend it to 3 players and add more cards, obviously. So we'll just say we'll say first player, and the first player. So how do we do this? It's the let's do this in a complicated way first. So if first player equals 1, then we know it's the first player's turn, and else it's the second player's turn first. And so we do it like this, and in the other case we would do it like this. And we would then say player 1, the card that player 1 draws is this. Actually, the card drawing is quite the same. Everyone draws the first card, right? So we don't have to even make that decision now. So because, okay, obviously let's do it like this. The second player, he will draw a card from his deck as well. But even if it were the second player's turn, both of them would have to draw a card. The only thing that is different is who picks the attribute of which, how these individual cards should compete with one another. Another thing to keep in mind, what pop does, it removes the card from the list. So now the card is removed, and after calling this twice, the array is now empty. So we should now give the card back into whatever array we have, so that it will appear again. So let's first do all of this again so that we're at the same spot and test how push and pop work. So let's do it for the first player. So if we do this, in the P1 card, we now have the card that is in the deck. let's assume this player wins. So we would then push the card back into his stack. So we would do dex 1, the P1 card. So that card goes back into his stack. And now I ran everything. So if I now have a look at the dex, okay, let's run everything again and not do this inside of this if loop. If command, that will make everything a little bit easier to first understand what we're doing, and let's remove this as well. So the idea is, if we look into dex 1, now I ran the whole thing, that's not what I wanted, sorry, have to do all of that again. And so where are we? The first player, his deck has the Mini Cooper and the Nissan. And if we pop the card and have a look at the decks, then we have only the Nissan, because we drew the Mini Cooper and now we have the Nissan. If we put the Mini Cooper back into the deck, we now see that the Mini Cooper who used to be in the front now is in the back of the deck. So by calling pop first and push, we take the card and add it to the bottom of the individual stack. So this is the right way to put the cards in order. So the other thing we need to do is we have the P2 card, and for this we need to pop first dex 2. We don't have a look at this. And let's assume the first player wins. What we then do is we push into the winning player's hand also the second card. So let's start all over again to see where we are. If we are here, so at the moment, if I look at dex 1, this one has 2 cards, the Mini Cooper and the Nissan, and the Mini Cooper should win against, I don't know, whatever P2 card would be, and then both of them should be added to the deck of the first player. Now the first player has the Nissan, the Mini Cooper and the Mustang, so he won with the Mini Cooper against the Mustang. And this is how it would go down if player 1 were to win. If player 2 were to win, then we would just change this number. And in a sense, what we do is we take the stash, no, how would we call it? The cards that are on the table. And we could do that. We could have a cards on table, which would be a vector of type car, just the cards on the table, and we initialize it with an empty set. And what we now do is we add the popped cards to this cards on table. So what we would do is, instead of having these variable P1, we would do push to the cards on table the pop first. This is the one that first player puts his card on the table, and then in the next step the second player will put his card on the table. And now we have these cards on the table, and what we would then instead of putting them individually there, we can also put all the decks that are on the table, all the cards on the table, into the individual decks. And we can run this from the start. Again, we're here. Where's my cursor? We'll create this now cards on the table. It's an empty set. We push the first card on the table from the first player, then the one from the second player, and now the cards on the table contains the 2 cards that are competing against each other. And imagine player 1 wins. He then gets those cards on the table. And this didn't work. Why? Cannot convert an object of type vector car to an object of type car. Okay, so we cannot push an item into a this is a collection. It is an array, and this is an array. And we cannot push an array in an array because we would then get an array of arrays. But there's a neat trick in Julia that says, okay, I want to push the things that are in here individually into the deck. And for that, we can use the ... notation. So this should work. Yeah, it does work. Because what it does, it basically says, okay, take what's in here and add them as individual parameters to the push function. So what it basically, this actually runs push exclamation point dex1, comma, cards on table 1, comma, cards on table 2, comma, cards on table, until all the cards on the table are unlisted. That's basically unlisting this list, or unarraying or unvectoring the vector that is in here, so this function works. And now this player has won these two cards. But we could now play the same game again. So by going in here, we reinitialize the empty table. The first player puts a car in. The second player puts a car in. And if the first player wins again, they are put on his table. And now we can no longer play because one player has all the cards and the other player has none of the cards. And now I think we should try to put this into a game loop. And the game loop, we do have actually some of this code already. Passive player will look at the value. So the actual comparison, that should happen somewhere here. The losing card goes to the winner's deck. That actually happens here. And here we don't say the losing card, we just say both cards. Both cards go to the winner's deck bottom. That makes it easier. Next turn is the winner's turn. But we didn't, so the first player thing. Let's not call this first player. Let's call this the active player. That's probably a better way to call this, because it's not if the first player is the first player, then yeah, that's the naming wouldn't be too good. So this should be in a game loop. We should repeat this, and we don't know how to do this. This we still need to do, and this we also still need to do. While we really should do this, we don't have to do this right now. I think the video has now reached a long enough time for you to have a break, and I can still remind you to keep following along and trying to figure out what we'll be doing next, maybe doing your own exploration of what one could do next, and I'll see you in the next video.